Okay, let's take a look at number 4. And the way I'll do this, let me go to this here. You want 4? Okay. So differentiate each function with respect to x. This is just a big nasty chain rule problem. So you got y equals all of this, negative 4, you got big parentheses around here, 4x to the 5th plus 3 to the negative 3 minus 1 all to the 1/5. Okay? So when I do this using chain rule, the outside part is the power. There is an inside power as well, but we'll have to wait till we get to that. So y prime is going to be equal to 1/5 times all of this, which is negative 4x to the 5th plus 3 to the negative 3 minus 1 to the negative what? 4/5. Then you do the derivative of the inside, which will be using power rule of the inside with chain rule. So you got to do the outside power here first. Okay? So that'll be negative 3 times negative 4x to the 5th plus 3 to the what?
Negative 4.
Negative 4 times the derivative of the inside, which would be this. Negative 20x to the what? 4th. And then times the derivative of negative 1, which is just a constant, so the derivative of that's 0. Correct?
Yes.
So, depending on how much you want to do to this, I don't know how much they did. I can just answer in a second here. Let's send to the basement what we should send to the basement and leave on top what we should leave on top. I definitely know the 5 is going to go to the bottom, correct? And then this goes to the bottom and we can put it back underneath the root. So it'd be the 5th root.
When you put a root, is that technically the simplified version?
Either that or to the positive 4/5 power. Doesn't really matter which way you do it, I guess. So you got negative 4x to the 5th plus 3 to the negative 3 minus 1, and all of that to the what? 4th power. Or you can just add it to the 4/5 power, that's fine too. This also goes to the bottom, doesn't it? Is that correct? The negative 4x to the 5th plus 3 to the 4th power. So what's the only thing left on top? Positive 60x to the 4th. And I don't know how they wrote their answer, but that's what I'm going to say is good enough.
Or you can cancel the 5s.
Huh?
Or you can cancel the 5s.
Yeah, I guess you could go 5 goes into, this becomes a what? 12?
I think it's what they have
Is
there.
that how they had the answer?
Yeah.
Okay. And people are like, well, what about this negative exponent on the end here? Probably not going to do anything with it because it's under a root. Okay? And I don't know if you're going to be able to simplify that out of that root, so just leave it as a negative exponent on there. I doubt you're going to see anything that's stupid looking, but there you go. All right, what next problem? In order. 6?
Part 6.
Oh, no.
Oh, right there.
Does it matter which part?
No.
No.
Does
Yes.
everybody know good with part A?
Yes.
Yeah.
Okay, good with part B?
Yes.
Part C?
Yes.
C?
Or part 4.
Or yeah, part 4?
3 and 4.
Okay, sorry. Part 5. I'll do part 5 and part 6. So h5 of x, this is just symbolic differentiation. So we have f of x to the 2nd power, and I want to find h prime of 3 of this 5th function, whatever we want to call it. They could have really, in my book, just called it h of x, but they're just saying, hey, we got 5 different h functions. They could have used 5, 6 different letters if they wanted to. So first of all, you're going to find h prime of find h prime. So I need to use chain rule over here, so I'm going to have 2 times f of x to the 1st power, then times the derivative of the inside, which is the f prime of x. So there's your rule symbolically. I'm getting ready to do a free response question in your next free response packet next week that has a symbolic differentiation problem on it. The only reason I'm waiting is because it asks you some other questions of stuff that I'm going to teach you next week, so I'm waiting on that one until I get that in. After we get next weekend, there's gonna be a lot of first months you're gonna be able to do, like a ton. And then we really just got integration stuff left to do. So I've got h5 prime of 3. Now in the AP exam, they won't use h1, h2, h3. They'll use different letters like F, G, H, W, R, P. They'll just keep using different letters. And they'll probably only have 1 or 2 functions anyway, so they're only gonna probably have to use F and G.
Q.
Yeah, Q. Yeah. 2 times, this would be f of 3 times f prime of 3. So then you just look at the table. It'll either be given in a table or a graph. They'll either have the graph of h, in this case h5, or they'll have a table for h5. Well, we got a table for h, or for f and g. So f of 3 over here is what? 4. So we have 2 times 4. And then f prime of 3 would be 0. So anything times 0 is 0, so that one's pretty straightforward. Any questions there? How to do symbolic differentiation. Okay, let's do part 6. Part 6, same thing. It's just going to be chain rule. F of g of x. It's just chain rule. In fact, it is our exact chain rule derivative. It's even the way I state it in the formula. So it'd be h prime, which would be the derivative of the outside function first. So it'd be f of g of x times the derivative of the inside, which would be g prime of x. It's just your chain rule formula, the way you were supposed to memorize it. And then I'm going to find h6 prime of 3, which would be f prime of g of 3 times g prime of 3. Well, let's start. What's g of 3? It's 4. So we're going to have f prime of what? 4 times g prime of 3. G prime of 3 is 0 again. Well, this is stupid. So no matter what, 0 times anything is what? It won't even matter what f prime of 4 is. F prime of 4, yay, it's -1, but it doesn't matter. Because -1 times 0 is still 0. But at least you can see how to get it, because I'm probably not going to have a 0 in there. Okay, any questions on symbolic differentiation? Okay, moving on. What else? 10. Now, the next big part of this is you've got to make sure you have your rules all memorized, because if you don't have the rules memorized, it's not going to really matter if you understand it if you don't have the rule memorized. Now, here's the thing. I do want to clarify something, because Billy's been asking questions on this, and let's make sure we know the difference, okay? Secant is not inverse cosine. And Billy asked me a question the other day that I thought was a really good question. Inverse cosine usually is written cosine to the -1 of x, but I think a lot of people confuse that with an exponent. When they use the -1 on a cosine, it is meaning inverse. If you can do secant, let me show you. This means arc cosine. It does not mean secant. Okay, let's make sure we clarify. It's not the same thing. Now, if you actually want to use a -1 exponent on cosine, okay, if you actually want to use a -1 exponent on cosine, not as an inverse, but as an exponent, then you cannot put it on the cosine, because that's the notation we use for an inverse. So if you want to use a -1 exponent on a cosine, you have to do it kind of the old-fashioned way, put it all in parentheses and make it to the -1. Now that's not inverse cosine, and we can't shortcut it by putting it on the cosine, because that means something different. This means secant, because this is really 1 over cosine. You get that? Okay, those are two different things. When we use the -1 in this situation, even though for every other power we can do that, it's just -1 we can't, because that has a specific meaning. It means inverse in that situation. So then this is okay. This is 1 over, and then you can use chain rule with this. Like you can, like we know the derivative of this. Like you know the derivative of this is what? Secant x tangent x. It even works though with this. Watch. Check it out. You go -1 times cosine x to the what? -2 times the derivative of cosine. Negative sign. Let's see if that equals secant x tangent x. Oh, what Come on, what about chili cheese dogs? Chuck, come on. There we go. So what happens negative times a negative? Positive. So we'll have positive cosine 1 over cosine squared x, that goes to the bottom, times sine x. And then we can make this sine x over cosine x times cosine x. This becomes a what? Tangent. And then you're left with a 1 over cosine, which becomes the what? There's your proof. But again, this is not the same as this though. When we use the negative 1 on the cosine, we're meaning arc cosine. Now in the AP exam, to really avoid that, they pretty much always use arc cosine, arc tangent, arc sine, arc cosine. But your calculator obviously doesn't. Does it put arc cosine? No, it uses this notation. And they do use both on the AP exam. And in fact, on the AP exam, in parentheses, they'll put arc cosine means cosine to the negative 1x. They'll even clarify that they both mean the same thing. That they're not talking about this situation. Okay? So really important. And I know that's such a pain in the rear end. Okay? But that's the way it is. This one right here, I imagine a lot of you think the third power might have been on the secant, but it's not. This is secant of 2x cubed, okay? Unless the whole parenthesis is around the secant, or the third power is on the secant specifically, that power is on the inside, not the outside. So the derivative of this would be y prime is going to be equal to secant 2x cubed tangent 2x cubed times the derivative of the inside, which is what? 6x squared, and then you can just bring the 6x squared out front, if you would like. Don't have to, but makes it look a little cleaner. Okay? And most of the time they are. What other questions? We'll get to the inverse one, but are there any other ones? 13? Same thing. Y prime? 12, okay, that would, yeah, because I was going to say that's not related to. Oh, inverse cosine. What's the derivative rule for inverse cosine?
Negative 1 over 1 minus the square root.
Okay, so negative 1 over the square root of what? 1 minus u squared times what?
U
Times du dx or u prime. Okay, du dx or u prime, either way you want to write it. All right, so y prime is going to be negative 1 over the square root of 1 minus 4x to the fifth, quantity squared, times the derivative of the inside, which would be just 20x to the fourth. So just negative 20x to the fourth over the square root of 1 minus, make sure you square the 4 and the x to the fifth, so that'd be 16x to the 10th. You multiply exponents when you go power to a power. That's it. Done. They're not going to be any harder than that on the test tomorrow. As long as you know the rule. The problem is some of you won't know the rule, and then it will be really hard. So I don't know how you're going to come up with a derivative without the rule. Okay, what else? Okay. 18. What's the derivative rule for natural log? Yeah, it's derivative rule for natural log of u would be 1 over u times u prime, which some of you just say u prime over u. It's the same way. I usually just go 1 over u and then times the derivative of the inside. That really doesn't matter. So anyways, y prime is 1 over 3x cubed times the derivative of 3x cubed, which would be what? 9x squared. So we're going to have 9x squared over 3x cubed. It does simplify. 9 and 3 divide out, so you get a 3, and then you get an x on bottom. Okay? What else? I feel like second go around on these, though, it's a lot easier. I'll be like, why did I miss these the first time? Because you probably didn't know the rule. 23? All right, y prime is going to be equal to 4 to the rule for this one. What's the rule for a to the u?
U times ln of whatever
Yep, a to the u itself
times ln u or ln a
ln a times
derivative u.
the derivative of u. So the only difference between this and e to the u is e to the u doesn't have the ln e because ln of e is just what? Ln of e is just 1. You don't need the ln of the base because you're doing natural log of e, which is just 1. So you just do itself times the derivative of the exponent. It's the only difference between a to the u and e to the u. Okay? And so it's going to be itself. I don't know why that sometimes is so difficult to write itself down. Because everybody wants to get anxious, man. You get anxious and you think, oh, I got to do something to it right now. And some people start trying to apply the power rule here. I mean, how many of you tried to apply the simple power rule here? You don't have to raise your hand. But think about that. How many people try to apply the power rule here? So you see a power. Guys, you don't use the power rule when there's a variable in the exponent. Ever. The only time you use simple power rule is when it's a simple power, which means there's no variable in the exponent. Okay? So, times ln of 4 times the derivative of the exponent, which would just be fixed 15x to the 4th. And you're going to do well.
Oh, can we have that
Okay,
sheet passed around?
I know,
Oh, okay.
because I handed out the free response. So I know who didn't know.
Wait, you didn't give me
Huh?
I didn't give you
And you weren't here this morning.
Oh, it might be on my desk. Okay, what else? Is that good? What else?
Do we have to know inverse secant?
Yes, you do need to know inverse secant.
And that is.
Yeah, I'll do one here in class today when everybody's here. Okay? You have the rule. Okay? It's on the rule sheet that I gave you. I'll just do an example. You just need to see one, so there's only going to be one on there
Another
tomorrow.
copy of that, or is that on the
It's on Moodle. It's like 2-3 weeks ago. All right, what else? You need a log one, or you want to go right to the inverse?
Inverse.
All right. Inverse rule. The derivative of an inverse function. Now this applies to any inverse. Now what is an inverse? An inverse is when you do what? Switch x and y. You certainly can do it that way if you want. Okay? You can actually take the function and find the inverse. So you can literally go to the problem and say, okay, this is really y equals 4x plus 3. And to find an inverse, I would just switch x and y. How many of you did it this way?
I did.
It works. It takes a little longer. In fact, on the AP exam, they're going to actually do it in such a way you won't be able to do this. Okay? And I'm going to show you a multiple choice problem like it, so you better learn the rule because they are going to do the problem in such a way you won't be able to do this because they're not going to give you the equation, they're just going to give you a bunch of numbers. They're going to say the inverse is that, here's a point on the original function, here's a point on the inverse, and you're just going to have to know the inverse rule to be able to do it. And I will illustrate one of those here soon. So learn this rule. But you can, if you forget the rule all of a sudden, you're like, well, if it's just a simple equation, you can do it this way. You switch x and y, and then you resolve for what? Now, this is pretty easy because it's linear, right? It's not very hard to solve for. So you get y is equal to x minus 3 over 4. Correct? And you can also write that as y equals 1/4 times x minus 3, which is just 1/4 x minus 3/4. Actually, you could leave it. Any 3 versions would be fine. Then you just find the derivative. And the derivative of this function, since this now is the inverse, this really is the inverse. You just find the derivative of it, which is just 1/4. Now, what was the derivative rule that I gave you? Because I always forget it. It's like 1 over... See, the derivative of an inverse, let's state it. I texted it, so somebody got it. You can always forget it. F inverse of x, it's, let me see if I remember it. It's 1 over the derivative evaluated at the inverse. Is that correct? Is that how it is? I can pull it up on mine. Let's see here. Yep, I got it. So the way it works, if you want to do the derivative of an inverse, if I actually want to do this, okay, the shortcut works like this. So the derivative of an inverse It's just the reciprocal of the derivative of this function. So find the derivative of this function first. What's the derivative of this? 4. So it's the reciprocal of that derivative. Okay, so it's 1 over the derivative of that function with the inverse plugged into that derivative. Okay? Now, the inverse, it doesn't matter what the inverse is because what's the derivative always going to equal? The answer is 140. So you find your derivative, and then you would plug your inverse into your derivative. But since it's constant, it's always just going to be 4. Now, what they're going to give you is they're not even going to give you a function. What they're going to do is they're going to give you the original function, or they're going to give you a value on the original function. They're going to give you points. And then you're going to have to use those points to think about how the derivative rule works. And I'll illustrate one later on. You'll see.
Seems pretty
It's a kind of a weird thing. Inverse is just one of those fuzzy things that always, I get it, but sometimes it just doesn't click for everybody. But anyways, it's just the reciprocal of the derivative evaluated at the inverse. So whatever the inverse is, this will eventually be a point. You just plug it into the derivative. Well, since the inverse is this, it doesn't matter what you plug in, you're just going to get 4. These are all linear, so they're so stupid. It's all going to be constant. I'll go back and assign a couple more tonight that are not linear, and it'll actually make a little more sense, probably. See, I've seen ones that are not linear, so this seems trivial to me. It's like it's just going to be a constant every time. Right, I'll do one more just to make sure. I'll do one of the other inverses too, but just to make sure. So what you would do, let's just shortcut it. So it's going to be 1 over the derivative of the original function evaluated at the inverse. So first of all, let's find the derivative of the original function. What's the derivative of the original function? -1. Now, here's the thing. I'm supposed to do the reciprocal of that and plug in the inverse. Since it's constant, it doesn't matter what you plug in, what are you going to get? -1. So it's just going to be the reciprocal of that, which would be 1 over -1, which is just -1. That's why this is so trivial. Okay. The other type of problem they had, was there one other type?
Yeah.
Okay. Where did it start? 27 or 28? Oh, okay, right away at the next one. So this one to me is a little more interesting. Because what you can do, and this is how you apply it. Okay, so watch. This is how the shortcut would actually come in handy. What I would do first is I'd plug in -2 into the function. So what's f of -2?
8, 5.
-4 times -2 minus 3, which would be 5, correct? Now, according to an inverse is just doing what? Switching x and y. So, what would the inverse be? If the inverse, you would flip them, right? So the f inverse of 5 would equal what? -2. That's it flipped, right? Inverse lets you go backwards. You start with the 5 and you go back to the 2. Okay, the function, you start with the 2 and you get to the 5. So you're just switching x and y. So that would be f inverse of 5 would be -2. Now here's how you would apply this. Oh, but they want to know f inverse of -2. Oh, that doesn't look good. Never mind. I'm going to do it the same way. I don't know what this one is. Dang it. Well, I guess we are going to have to find the inverse. But you might find the inverse and find out what f inverse of 2 is. What's the inverse? So you switch x and y, be what? Is it x plus 3 divided by -4?
X plus 3.
Is that it?
Yeah.
Okay. Good? So then f inverse of -2, f inverse of -2 would be what? -1/4, correct? Now, you want to find the derivative of the inverse at -2. So according, the shortcut would be 1 over the derivative of the original function evaluated at the inverse 2. What is this?
Negative.
Negative 1/4. So it's going to be 1 over the derivative of the original function evaluated at negative 1/4. So we find the derivative of the original function. Well, again, this is silly because it's a constant. So the derivative of this is what? Negative 4. No matter what you plug, I can plug anything into, fine, I'm going to plug negative 1/4 into it, but whenever I plug into it, I'm going to get what? Negative 4, so I'm going to end up with what? Negative 1/4 again. They're way more interesting than this. These are boring. I don't even know how this program even has these problems. So I'll assign a couple more that are a little bit different tonight.
Like if you plug A into X,
What do you mean, A?
negative 2 is basically f of A.
They're calling XA in the directions.
So it's like f of A.
Yeah, they do that quite a bit. They'll say, yeah, it's like f of A. It's changing the variable over from A to X. Usually they use, remember when we do continuity, it's always X equals C or X equals A. Same thing with the alternate form of the derivative. They'll change the constants. They either use A or C or K for constants. Okay? Any other questions? All right. I don't know if I might have much time for response. Let's go to the other one. This one I doubt there's hardly any questions on. Guess we'll see. Review of basic derivative rules. I don't have the answer key for this one, so how about most of you, I feel probably are fairly confident that you got them right. So if there's one you were stuck on, or if you feel like you need to see the answer, certainly can do it. Can't find the answer key for it. All right. I imagine 1 through 8 we're okay on. A lot of those I probably could do in my head, but I'm just in the interest of time. I trust you got them right. 9, anything 1 through 12 that you would like to see that you just think, I don't know if I got that one right. 10, I can. And that really kind of summarizes all of 1 through 11 anyways. So what I would have to do to this first is I would have to move this to the top, right? So that'd be 2x to the negative 2/3 minus pi x squared plus x root 2. So when I take the derivative of this, it's just going to be 9x squared negative 4/3 x to the negative 5/3 minus 2 pi x plus root 2. That's linear. And then just move this one to the basement. Done. Okay? You don't need to get a common denominator when it's this complicated. Okay, I'm not expecting you to move this to the basement and say, ooh, I need to get a common denominator for all these things. No, you don't need to do that. You just leave that one fraction in that problem, and they're not going to have a problem with that. Okay? Going down. Just more trig stuff. 12 through 14, is everybody okay?
14.
What I would do is just use constant multiple rule. It's really just negative 1/3 cosine x. So the derivative of that would just be constant times the derivative of cosine, which is negative sine. So it'd just be positive 1/3 sine x. Alrighty? 15 through 23, are there any questions? 17, if you missed this one, I'm mad. Let me just go ahead and bring up 22. 20, you missed this one, I'm mad.
I definitely missed that one.
Why are you doing quotient rule?
How do you know that equals cotangent?
Because I know trig. That's a trig identity. That's your quotient identity. You're supposed to know sine over cosine's tangent, cosine over sine over cosine's tangent, cosine over sine is cotangent.
Really?
Those are good ones to know.
Yeah,
Probably because you haven't had trig for a while. They just had it. Good first try. What else? Can you do these? Anybody want to do product or quotient rule down at the bottom here? There's a lot of product quotient rule down here.
Do 23.
23. This is actually a really good one to do because they do a lot of e to the x stuff on the AP exam. And one of the things they do, I want to just bring up here now that we're talking about it. So we're going to have the derivative of the first function, which is what? E to the x times the second function, sine x, plus the first function, which is just what again? Times the derivative of the second function, which is what? Now, that's the answer. You're done. You don't have to do anything else. But later on, you are going to have to do this. In fact, starting next week, you're going to have to do this. They are going to, because we're going to be doing more with it, we're going to be finding what's called relative maxes and mins and absolute maxes and min and concavity and all that stuff. And we're going to have to start factoring these things. And one of the ways you're going to factor is anytime you can factor out an e to the x, it's a great idea. It's not a good idea, it's a great idea. Okay, so this one could also be, and this won't even be an or later, this will be you want to do this. It'll be e to the x times sine x plus cosine x would be even a better answer. I'm just telling you, you're going to want to do that next week. Because e to the x is something that later on, if I was asked you to find horizontal tangents, for example, how would you find horizontal tangents? Set the derivative equal to what? And the reason this works out so nice is when you set the derivative equal to 0, you have e to the x equals 0, and you'd have sine x plus cosine equal to 0. This is awesome that you got this out because think about e to the x. What is e to the x? What's your graph of e to the x? There's two reasons why this is what it is. It's a J-curve, and I'll go over this again when we get to it. It's a J-curve, which means e to the x, can it ever equal 0? So once you get it factored out, you're able to just do what with it? Ditch it. That's why I want to get it out, because almost every time you're going to be able to throw it out. Because it can't ever equal 0, and some people are like, why? I get why the graph never crosses, but why does that really work? Try and take the natural log of both sides, because that's what you would actually do to solve it, right? Can you take the natural log of 0? There again is why it doesn't work. This over here would be pretty easy because you get sine x equal to negative cosine x. And everybody knows sine and cosine are the same. Okay, sine and cosine are the same, but I don't want to know when they're equal. I want to know when they're opposites. When are sine and cosine opposites of each other? At what reference angle? They're almost identical, but they're not the same, but they're opposite. Come on, simple unit-circle value. Which pi over what? When is sine and cosine opposites on the unit circle? When what? It's not going to be when one's 3 over 2 and one's 1/2. Those are not opposites.
0, 1.
Huh? When one's positive and one's negative and they're the same value.
Pi or 2
Pi over 4s. But where pi over 4? Pi over 4 would be both root 2 over 2.
2 and 3.
Quadrant 2, which would be, sorry, over here for you, quadrant 2 and quadrant 4, which would be what pi over 4s? 3 pi over 4 and 7 pi over 4s when they'd be opposite each other. So this would be x equals 3 pi over 4 and 7 pi over 4 if the question was find horizontal tangents. Now obviously the question wasn't that, it was just find the derivative. Okay? A few more minutes, I'm probably not going to go the whole time, but let me just finish this up at least. 24 through 26, any questions there? What? Oh, 27? Let me look at it. And I use delta x's this time. What do I usually use? Okay, just let's look at the first one. You got the first of all, I know it's not C and D. How do I know it's not C and D?
Because they're stupid.
There's no limits. Can't do a derivative without a limit. So definitely not that. Okay? Just check these. So it's supposed to be f of x plus delta x minus fx over delta x. So f of x plus delta x. So it's got to be negative x plus delta x quantity squared. This is kind of looking good there. Plus x plus delta x. That looks good. So that's your f of x plus delta x part. Or your f of x plus h. Minus the function. That looks good. Over delta x. So the answer has to be B. I know it's not A. The only other option would have been E.
Why isn't it
Because the first part of it's not done right. Because you have to put x plus delta x in for both parts. You got to put x plus delta x in there, and an x plus delta x in there, which is going to give us the
A?
opposite of x. You see it? All right, 28 is always fun. Let's talk about this because everybody kind of been getting confused on this. What do you worry about when you see a flying? What do you worry about when you see absolute values? Sounds so kindergarten. You worry? No. A flying V is a flying V discontinuous ever?
No.
Not that I know of. Okay, does a flying V have a jump? Does it have a hole? Does it have vertical asymptote? So you can go ahead and knock out number 1. It's not 1 at all. You can't definitely do that. Or sorry,
It
it is 1. Thought I said discontinuous. It is 1. 1 is good. Okay, it is continuous at x equals -1. So we're like, well, wait a second. At -1, there's a corner. That's not discontinuity. What is that? That's non-differentiability. So it is non-differentiable at -1. And how do I know it's at -1? You can always find the corner of an absolute value or the cusp or the corner when you set the inside equal to what? Set it equal to 0. That's where your splice point happens for an absolute value. Because your absolute values, it changes from negative to positive. So you just need to figure out it equals 0 and figure out where it's going to change from negative to positive. Okay? So if you set the inside equal to 0, you'll figure out where the corner's at. So it's -1. So it is non-differentiable, so 2 is out of the question. And then F, does it have a corner at -1? That is true. So it is continuous and has a corner, which is why, listen, continuity does not imply differentiability. Differentiability implies continuity. So if the function is differentiable, it has to be continuous. But if it's continuous, it doesn't have to be what? There here. So look at it here, this problem. So the answer would be what? D, 1 and 3. I've got to do more of these questions with you guys because it's very clear to me you guys don't totally feel confident on them. So I've got to do a lot more of these. And then the last thing here, and then we'll stop today. Actually, notice that the first response packet I gave you, I have all the videos made from them last year. But I probably will try and still go over them at some point. Let's just finish this up and we'll call it good. Sketch the derivative 29. How would you sketch the derivative of this one? 30, how would you sketch the derivative of this one? How many times would the derivative cross the x-axis? I'm going to do it right here. It's better to do it on it. So it starts negative slope, so where would the derivative be? Below, then they go a little bit above, a little bit below. Look like that? Everybody in agreement? All right, 34. For the following graphs, specify why the function is not continuous or non-differentiable. Let's look at 31. Any discontinuity? No. Any non-differentiability? Where? At the corner. 32. Any discontinuity? No. Any non-differentiability? Where? At the cuspy corners. Any discontinuity? Yes. Where? Vertical asymptote. Any non-differentiability? Yes. A discontinuity is automatically a non-differentiability.
Just for fun, will you draw the derivative?
Yes, I can draw the derivative for fun.
32.
Of 32. All right, so this would start negative slopes, and it's probably like that, more like that, I guess.
When did it start?
Isn't that a line? Or are those actually like curves?
They're probably curvy.
Oh.
Okay, lines, whatever. But they have to. All right, you did lines then?
Yeah.
Okay, so you're assuming this is a V then. Okay, so line. So what would you estimate that slope to be? -7. So it's going to be down here at -7. Oh, just way down here. Okay, let's go with that. Okay, then this is a parabola though, and it's coming steep. But parabola, if this is a parabola, it's going to be linear, right? So it goes positive slopes to a slope of what?
It's negative. Just assume that's.
Well, that has to be a hole because we're coming in past the corner, so look like this.
Yeah.
Remember draw like the positive slope.
Yeah, you did.
Positive slope is above,
Oh, yeah,
negative slope below,
And,
and then up here.
yeah.
That's so much different.
Well, you're assuming, listen, here's why. You're assuming these are lines, so the derivative would be horizontal lines. You're assuming this is a parabola, so its derivative would be a straight line. Pretty good. All right. If somebody would like to stay behind and help me get the stuff that needs to go in the refrigerator.
I go to these.
Phenomenal.
I have, yeah,
Yeah,
I
that's
have
what
stuff right now.
While you're driving.